Hello everyone, welcome to Vardhaman College of Engineering. I am Dr. Srinivas Reddy, Assistant Professor, Department of Computer Science. Here we are discussing about Introduction to Graph Theory, which are useful in the field of data structures and relationships in algorithms, even day-to-day life like statistics, graph, bar chart, pie chart, etc. Now, basically we can represent graphs in two types. First one is directed graph, second one is undirected graph. Basically we can use representation of graphs are two types. First one is directed graph, second one is undirected graph. Now come to the main definition of graph. The main definition of graph is nothing but collection of ordered pair of vertices and edges. Collection of ordered pair of vertices and edges. Now we can discuss about this basic terminology of this graph. Basic terminology, we have mathematical representation, a graph G is equal to E comma V. Here E is nothing but edges, even we can call it as connections, etc. And V is nothing but vertices, even we can call it as points or we can call it as nodes. So today's class is about introduction to graph theory. The study about graphs are called graph theory, which are useful in the field of modeling networks, data structures, and relationships in algorithms. Even day-to-day life like statistical graphs, bar graph, pie graph, etc. The main definition of graphs are nothing but collection of ordered pair of vertices and edges. Now come to basic terminology. So mathematically we can represent graph is G is equal to E comma V. E is nothing but edges and we can call it as connections also. V is nothing but vertices, even we can call it as points and nodes also. Now come to examples for graphs. So we listed two types of graphs. First one is undirected graph. A graph in which each edge is representing with no direction. Each edge is representing with no direction is called undirected graph. So mathematically we can write as G is equal to E comma V. So no edge having direction. So there is no direction of each edge. So we can see some examples for undirected graph. So this is vertex 1, vertex 2, V1, V2. The connection between V1 and V2 is called here edge. We can define E1. So E1 we can define as the connection between the two vertices V1 comma V2. Even we can define the edge of a graph is the connection between any two vertices. Now, so this is a graph. We are having two vertices, one edge. So there is no direction here. This is one example. Now we can see second example for undirected graph. Here we are having three vertices, three edges. There are three vertices over there, three edges over there. So clearly there is no particular direction between any two vertices. So these are two examples for undirected graph. Now come to directed graph. Shortly we can call it as digraph. The basic definition of directed graph, a graph G having each and every edge is assigned with some direction. So we can define as G is equal to E comma V. And the graph is, initially we can take it example for two vertices and one edge. So this is V1, this is V2. Yeah. So here we are having some direction. The direction is defined from vertex V1 to vertex V2. So this is a graph G1 directed. Next, we'll see second example for directed graph. There are three vertices over there. Let us call V1, V2, V3. And we can define edge 1 is E1, edge 2 is E2, edge 3 is E3. Each and edge is weighted with small e1, small e2, small e3. Now we can define the direction v1 to v2, v2 to v3, v3 to v4. So positive clockwise, positive clockwise. So clockwise direction is there. So there is a direction defined from v1 to v2, v2 to v3, v3 to v1. So this is example 2 for directed graph. Just we can recall it. Today class is about introduction to graph theory. The study about the graphs are called here graph theory, which is useful in the field of data structure, modeling networks, and the relationships in algorithm, even day-to-day life like statistical graphs, pie chart, bar chart, etc. So the basic definition we have seen, the types of graphs are two out there: directed graph, undirected graph.